All right, that does it for our tour of sensors and shields. Let's look next at how to get this fun little IoT device talking to its neighbors by looking at communications hardware. These little devices aren't as much fun if they can't talk to other devices and to the cloud. Networks of devices and cloud-connected device scenarios are what make the projects really start to get interesting. We've got a lot of options for communication, but they all have their pros and cons, so I want to equip you to decide which method is right for whatever it is that you're building. If you're working on a device that you already know is going to be sitting in your house or somewhere else where you might have a constant Ethernet connection, then this is definitely a good way to go. You'll be all but assured of getting a high data rate and excellent reliability. Most devices in the IoT space, though, are moving around and they don't qualify for an Ethernet connection. So the rest of these communication methods that we're going to look at are wireless. All of these methods are going to use the RF spectrum for communicating. RF stands for radio frequency. Remember in high school physics when you learned that magnetic flux induces current in a wire, and vice versa, that if you run current through a coiled wire, it becomes an electromagnet? That's what we're doing here. We want to transmit and receive RF signals, so we build a device called a transceiver, that's a transmitter and a receiver, that takes our data in the form of electricity and runs it through a coil of wire to create a magnetic signal that propagates through space. Then a transceiver in another device picks that signal up and turns it back into a digital data signal. Now, it's possible to use sound and light as well, but I'm not going to cover these less common approaches. You've likely used Wi-Fi, the tried and true 802.11 method for communication. It's great for its high data rate and it's way popular, so you'll find hotspots all over the world. And you can even use Wi-Fi directly between devices without relying on a hotspot. But it does use a lot of power on the device, so you'll be better off if you have wall power or a big battery for your Wi-Fi solution. Bluetooth and Bluetooth LE are very good modern options. Bluetooth Classic, not as much, since it forces devices to go through a pairing ritual before they can chat. Bluetooth LE, on the other hand, is very exciting. It has a very low data rate, which is often perfectly acceptable in IoT scenarios, and especially considering the fact that this gives it very low power usage. I mean very low. A Bluetooth LE transceiver can run for years on a AA battery. One of the weaknesses of BLE, as folks like to call it, though, is its dependence on a star topology. This isn't always the best network topology for sensor and device networks. BLE works great with phones and computers since most of them ship with BLE modules built right in. XBee is a cool standard in RF communication. Like BLE, it has a low data rate and low power consumption, and it has the added advantage of implementing a full mesh network. This means that all XBee transceivers propagate the message to every other transceiver, covering as much area as possible. This is great for sensor networks and for applications such as home automation. NRF24 is an RF protocol that has a whole lot of positive attributes, but widespread awareness and adoption of it are not among them, at least not compared to the likes of Wi-Fi and BLE. It has a lot of cool features like low power modes, multiple channels, channel hopping, frequency calibration, CRC for message fidelity, and retransmit for reliability. Cellular communication usually uses the common GSM format and has the huge advantage that there are already cell towers just about anywhere in the world that there are enough people. You can find GSM shields for your device that instantly give it the ability to talk on this cellular network. And we talked earlier about Particle's new Electron device that's planning to build that right into the tiny device as well as offer a small, inexpensive data plan. There are other ways too to get on the RF bands. You can find a lot of proprietary RF communication out there. Your garage door openers, wireless keyboards and mice, just about anything else that's wireless but neglects to implement one of the standards that I've outlined. I've seen projects online where folks hacked into these wireless devices and started communicating over RF using these proprietary signals. And that does it for the device landscape and a little tour of some of the components, sensors, and shields that you might want to use in your project. Now let's narrow the scope down to a single device, the Intel Edison.